For 9.3b, we're going to evaluate trig functions given a point, and we'll be finding reference angles. So for example 1, we're going to find the 6 trig functions for the angle theta. So you can see we're given the angle theta here. We have a point on our terminal side. Now the way we're going to do this is I'm going to exaggerate that point, and then we're going to make a triangle out of it. So I'm going to draw just this quadrant for my x and y axis. I'm going to put in my line, but I'm going to exaggerate that point so we have more room. So let's say my point is there. That's still going to be my point 1 minus 2. Now what I want to do is draw a line from my point to the x-axis so that it makes a right angle. So we're going to make a right triangle. Now the point actually tells us the lengths of the sides, right? My x value is 1, my y is minus 2, so over 1, down 2. We're going to use these sides to find the hypotenuse. Let's just call that r. Pythagorean theorem, a squared plus b squared is c squared. So 1 squared plus negative 2 squared is going to be r squared. Or 1 plus 4 is r squared. 5 is equal to r squared. We can square root both sides. So my r is equal to the square root of 5. Now this works because our angle theta and this new angle right here we'll call theta prime, they share the same terminal side. So taking the trig functions of this angle, we'll have the same values as that angle because they're in the same place. So for reference, I'm going to redraw my triangle with its values, and then we'll find our 6 trig functions. So my right triangle is 1 minus 2 and root 5. That's the angle I'm going to be using. So sine theta, sine is opposite over hypotenuse. Opposite hypotenuse. So minus 2 over root 5. We do need to rationalize the denominator. So multiply by root 5 over root 5. So I get minus 2 root 5 over 5. Cosine adjacent over hypotenuse. Need to rationalize again. Tangent, opposite over adjacent, minus 2 over 1, which is just minus 2. So cosecant, hypotenuse over opposite. Cosecant is related to sine. We will talk more about that on another problem. again, cosecant, hypotenuse over opposite, or root 5 over -2. Secant, hypotenuse over adjacent, or root 5 over 1, same as root 5. Cotangent, adjacent over opposite. Adjacent over opposite, or 1 over -2. Okay, so let's define a reference angle. So for example 2, we're going to draw angles that are given, find the reference angle. So a reference angle for theta is the acute angle theta prime formed by the terminal side of theta and the x-axis. It's a bit of a mouthful. Let's write that down and then we'll draw it. It'll make more sense once we draw the picture. So the reference angle for theta is the acute angle theta prime formed by the terminal side of theta and the x-axis. Okay, so first we want to draw theta is 5 pi over 3. So it's always a good idea to have your unit circle handy. I got mine right here. So we're going to find 5 pi over 3 right here. So let's draw that in. So 5 pi over 3 goes about right there. So this is our theta. This line right here is our terminal side. And then the angle theta prime formed by the terminal side and the x-axis, or right here. That is your reference angle. So the reference angle is always going to be from your x-axis to the terminal side. Now, the way we can find it in this case, well, a full circle is 2 pi. If I take away 5 pi over 3, I'll be left with my reference angle. So I want a common denominator, so I'll multiply by 3 over 3. So it's going to be 6 pi over 3 minus 5 pi over 3, or just pi over 3. So that's going to be my reference angle, or my theta prime is pi over 3. Okay, so B, we do the same thing. So negative 130. So if we start here, we're at 0. So up is positive, down is going to be negative. So we're going the opposite direction. So 0, 90, 130 is definitely less than 180. So we can say about right there. So that's my theta, my minus 130 degrees. So our reference angle, or from the x-axis to your terminal side, that's going to be our theta prime, our reference angle. Now in this case, we can notice that from our starting point to here is 180. If I take away my 130, I'll be left with my reference angle. I can say 180 minus 130 will give me 50 degrees, which is going to be my reference angle. Theta prime is 50. Okay, so example 3, again, we want to draw the angle, identify the reference angle, and then we're going to evaluate the angle for the given trig function. And the idea behind this is the given angle and the reference angle will give you the same value. Most of the time, the reference angle is going to be an easier value to use. So we're finding the reference angle and using that to evaluate the trig function. Now, before we jump into that, there's a couple things that are going to be really useful. So one of them is, again, your unit circle. Make sure you always have that. And then there's a couple other things I want to show you. So real quick about the unit circle. So say this is our unit circle. We have some point. This is our theta. And then we have a point here, and we have values for all of them. Well, this point, this xy, comes from the cosine of theta and the sine of theta. So if you made this a triangle, you did the cosine of theta, it's going to give you this value, the sine of theta, it's going to give you that value. So we're going to use this along with, so there's some relationships with the trig functions. So remember, sine is, what is it, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Now tangent Well, we know what tangent is, but I'm going to tell you something else about it. Tangent is also sine over cosine. And we can show this really quick. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse. Well, fraction divided by a fraction, stay, change to multiplication, reciprocal. Hypotenuse over hypotenuse cancels, and we're left with opposite over adjacent, which is tangent. So similarly, cosecant is the reciprocal of sine, or I can write it as 1 over sine theta. Secant is the reciprocal of cosine, or I can say the secant theta is 1 over cosine theta. And then cotangent theta is the reciprocal of tangent, or cosine theta over sine theta. So if we use finding a nice point, these are cosine and sine, along with these relationships, it's going to make evaluating our trig functions a lot nicer. All right, so let's do our examples. So for A, first, draw the angle, identify the reference angle. So negative 240. So again, 0, 90, 180. It's going to be less than 270, so put it about right there. So our reference angle from the x-axis is going to be here. So that's going to be our theta prime. And we can see if this is 240, if I take away this bottom piece, 180, we'll get my reference angle. Or I will say the entire angle 240 minus 180. So 240, take away 180, will give me my theta prime, which is 60. Now 60 is a really nice angle. So if we want to find the tangent of 60, you go back to your 30, 60, 90 special triangle, do opposite over adjacent. It will definitely give you the right value. We can also go to our unit circle. So if we go to our unit circle, so tangent of 60, so we look at 60, we can see our point right there, which is 1/2 root 3 over 2. Let's write that down. So on our unit circle at 60 degrees is the point 1/2 and root 3 over 2. And then remember, that is cosine, and that is sine. Tangent is sine over cosine. So I can say the tangent of 60 is the same as the sine of 60 over cosine 60, or root 3 over 2 over 1/2. So stay, change to multiply, flip. I'm left with root 3 over 1 or just root 3. Now again, if you're not comfortable with this, you can always go back to your special right triangle. So 30, 60, 90. And you remember the relationship, short side, hypotenuse is twice as long, long leg, short side times root 3. And then we can say, okay, well, if I'm going to do the tangent of 60, that's going to be opposite over adjacent. X divided by x is 1. I'm left with, again, root 3. Okay, let's do B. So cosecant 17 pi over 6. So we could count by pi's over 6 and go around the unit circle until we get to 17 pi over 6. But we can also remember that we can add or subtract 360, or in the case of radians, add 2 pi or subtract 2 pi to get to the same place, because it's a full circle. So 17 pi over 6, again, take away 2 pi. So we want a common denominator, so multiply this by 6 over 6. So 17 pi over 6 minus 6 times 2 is 12 pi over 6. That will get me to 5 pi over 6. All right, so that is on our unit circle. 5 pi over 6 is right here. So if we were to draw our theta for 17 pi over 6, we would start here. We would have to do a full circle, because that would get us to 12 pi over 6. And then we need 5 more to get us to 17 pi over 6. Now, we already found that just from here to here is 5 pi over 6. So just from there to there would be 5 pi over 6. But I want our reference angle. So I want this angle right here, our theta prime. So we have a half circle here. Remember, a half circle in radians is pi. So half is pi. If I take away my 5 pi over 6, I'll get my reference angle. So pi minus 5 pi over 6, common denominator. So multiply by 6 over 6. 6 pi over 6 minus 5 pi over 6 is pi over 6. So that's going to be my theta prime, pi over 6. Again, pi over 6 is a nice value. It's on our unit circle. So we take a quick look. So pi over 6. So that gives us the point root 3 over 2 and a half. Let's write that down. So at pi over 6, we have the point root 3 over 2 and 1/2. And then again, the cosine of our angle is that. The sine of our angle has that value. Now, if I want the cosecant of my reference angle, the cosecant of pi over 6, well, the cosecant is the reciprocal of sine, or we can say this is the same as 1 over sine pi over 6. And the sine of pi over 6 is 1/2. So let me draw this right here. 1 over 1/2. 1 times the reciprocal, 2 over 1, which is 2. So the cosecant of 17 pi over 6 is 2.